Next up, we get to implement deck, and deck is a bit more complex. So I'm going to just delete that for now, copy and paste all of our requirements, and then everything that we write will go below the requirements. We could make a separate file, totally works as well, but I'm going to do it just in the same file to make it easier for the video and for you to see the solution. So let's begin. We define our deck class, and we need to have our init method take self no matter what, but we're actually not going to pass anything in because at least the way that this exercise is written, every deck is the same. There are definitely ways that you could expand on this. I think I mentioned this earlier. There are games like in Las Vegas, I think they play with at least 2 decks, sometimes 4 decks, depending on the game. They put them all together and shuffle them together. So you could allow this, to have like number or quantity or something. But we're not going to get into that, just self. But what we do need to worry about is inside of init, we're going to create a cards attribute with all 52 possible instances of card. Okay, so we know that self.cards is going to be a list. But what we want is every possible combination, basically between, what do we have for the suits? So that means hearts, diamonds, clubs, and spades. And I'll start by just making that into a list and just call that suits. I'll fast forward to the next part. I'm going to define the values. Okay, I added the values list now. All strings, just to be consistent, because we have, A for ace, K for king. You could do this, but then it would be kind of confusing dealing with ints and strings. So everything's a string. Ace up to king. And I guess ace is low in my example. Okay, so as far as taking these two things and making a new instance of card, we basically want to do this, right? Card of ace, comma, hearts, and then the same thing except ace, diamonds, ace, clubs, ace, spades, and then go to 2 of hearts, 2 of diamonds. And we want to take each thing and add it in to cards. Maybe the first way that might come to mind is to use a nested loop. So for something like for suit in suits, and then we want to double loop for value in values. We're going to call card, and then what do we want to pass in? Pass in the value first and then the suit, just like that. And we could just start by doing a print card, just see if it all works. And to run this, I need to do a deck. We don't even need to save it to a variable, just initializing any deck. We'll run this code and it should print if I have my parentheses so we don't get an error. Let's see what happens. All right, so you can see it goes through. It starts with hearts and does ace through king of hearts, and then it goes to diamonds, and then clubs, and then spades. So here we're just printing them. So what we could do is take self.cards, and then instead of printing, we could do a append, self.cards.append, like this. And this is perfectly valid. If this is your solution, that's great, it works. And at the end, we can just print cards, self.cards, and we get this list. And the reason we're seeing, A of hearts, 2 of hearts, 3 of hearts, instead of those card objects is because when we print a list full of card objects, each card is printed out according to whatever we defined here in the repr method. Okay, so this is totally valid solution, but we can also do it in a more Pythonic way using list comprehension. And it looks like this. So we're going to create a card with value in suit, and we'll just do for suit in suits, for value in values. And you could swap these and do for value in values, for suit in suits. But this is basically doing the exact same thing, but in a list comprehension, we don't have to append manually like we're doing down here. So I prefer that way. And let's just make sure I didn't mess it up. Let's print self.cards again. Looks good. Okay, so we've checked off this first little bullet point. Next, nice and easy, deck should have an instance method called count, which returns a count of how many cards remain in the deck. All right, so it's an instance method. So down here, we'll just do a def count, and we need self in there. And all we want to return is what? The self.cards list. We want to know the length of that list. So it's just len self.cards, and that should be it. So let's now save d to a variable and just do print d.count. And we should see 52, and we do. Make sure it works, do d.cards.pop, and run it again, and we should see 51. Perfect. Okay, so we're done with those first two. Next, deck's repra method should display information on how many cards are in the deck, like deck of 52 cards, deck of 12 cards, etc. So we'll do def repr. I like to do these up top, all the dunder methods together, and that also needs self. And all we will return, again, if you're using the Udemy test that I wrote, then you want to use .format. Unless they've upgraded to 3.6, I will post an announcement about that. But if they haven't, use .format. But I'm going to use an f string. And all that we'll do is, we could use len of self.cards, but we've already written that here as count. So I'll just write deck of, and then in here, we just call self.count cards. Perfect. So now if we make a deck, we can just print the deck, and we should get deck of 52 cards, assuming I didn't mess anything up, and it looks good. Deck of 52 cards. Okay, and we can trust, because count was working when we popped one off, we can trust that it still works just fine. Nothing has changed in count. All right, so that's 3 done. Next, deck should have an instance method called deal, which accepts a number and removes at most that many cards from the deck. It may need to remove fewer if you request more cards than are currently in the deck. If there are no cards left, this method should return a value error. Okay, there's a lot of pieces to that. Let's start by just defining it. Def deal self, and then the number of cards that we want to remove from self.cards. So the idea is, if we call, and this is going to be an internal method that we only use, we're going to create deal hand or deal card and deal hand in just a moment, that will then call _deal. And the first thing we'll start with is just checking how many cards are in the deck. So let's just make a variable called count equals self.count. And then what we want to do is test this against the number that's been passed in. Let's say for some reason someone wants to remove 53 cards. Well, there's only 52. So what we want to do is compare the num that's been passed in with the count, how many cards are left. And basically whichever one is lower, we will use. So if a more realistic example, let's say that there's only, I don't know, I'm going to just represent each card as a C. Say there's 3 cards left and the user wants to remove 5 cards. Well, we're going to only remove 3. So we'll take the least of them. So what we can do is use that little built-in function, min. And we want to find the minimum of count and num. So whichever one of those is lower, we'll save it to a variable. And let's just call that variable, I don't know, what should we call that? Actual, the actual number we're going to remove. And let's just add a little print here that says, going to remove, and then actual cards. That needs to be an F string in order to work. Okay, so let's test it out. The beginning D is deck. There's 52 cards. If I try and do D dot, even though we're not supposed to call _deal from outside the class, we can, just for the testing purposes here. But as developers, you should respect that. D dot _deal. And then let's try to get rid of 54 cards. Okay, let's see what happens. And we get going to remove 52 cards. But if I was going to remove 5, it tells us we're going to remove 5 cards. So it's just taking whatever is less. Okay, so that works. There is a problem though, which is if the count of the cards left is 0, and somehow this got called with num being 0, they're trying to remove something from an empty deck. Let's handle that case. So that will just be a simple if count equals 0. If there's 0 cards left, and we could actually even just do that at the very beginning. If there's 0 cards left, what do you want to do? Let's raise an error. And I think the specification is here. Let's see. All the way over. There we go. Value error with the message, all cards have been dealt. Okay. So we need value error, all cards have been dealt. Perfect. Okay, so next we want to take our list of cards, which is self.cards, and let's say num is 5. We want to take the last 5 cards and return those as a list, but we also need to make sure we're removing them from self.cards, because to deal a card, it needs to come out of the deck. We're not just taking the 5 values and keeping them in there, because then we'll always get the same 5 cards. We want to remove them from the deck. And what we can do is actually use a slice. So if you don't remember the slice syntax, what we're going to do here is go from negative actual to the end. So actual is going to be the number of cards we're removing. So let's say we have a list that looks like this, and actual is going to be 3 cards. So we're going to go 0 or back 3. So this is going to be back 1, back 2, back 3, and then take that slice all the way to the end. That's what this colon signifies. So then that's going to give us this slice, and we'll save that to a variable. Let's just call it hand equals self.cards, or actually let's just go with cards. Notice it's different than self.cards, it's cards. And then what we want to do is actually update self.cards so that it now goes from the beginning of the list up until what we just took off, even though we didn't take it off, but what we want to remove is at the end. So to do that, we're going to do self.cards equals self.cards, another slice. We go from the beginning, so that's colon, to negative actual. So now we're going to go from the beginning up to, let's say actual is 3, negative 1, negative 2, negative 3. We go from there to there, and that's what self.cards is. And then the last step is going to be return cards, which is what we took off. Okay, so one thing I did notice here, I need those parens after my value error. Let's test this all out by making our deck, and then let's start by dealing 3, and let's print it so we can see what we get back. And then to verify it's working, let's do print d.count. Okay. All right, so we have the 3 cards that were dealt returned here, and then the count is now 49 instead of 52. Of course, we are getting J, Q, and K, Jack, Queen, and King of spades because they are the last things. There's no shuffling just yet, so we always get the same thing. And let's just check one more thing. Let's get rid of this print. We don't need to print those cards in init anymore. But now let's try afterwards. If we deal all the cards, so that'll be 52, and then I try and deal, 3 again afterwards. It goes from here's all 52, count is 0. Now we get this value error. All cards have been dealt. Perfect. Okay. Moving on along, we have shuffle, deal card, and deal hand. Let's go with deal card and deal hand first because they're very similar. So down here, I'll define deal hand first. So def deal hand, or let's do card. I lied. And this always just deals 1 card. So it doesn't need any parameters there. And all we return is the result of calling self._deal and then passing in 1. But the thing about, deal card, it should return a single card, so not a list. And right now, if we call deal_deal with 1, it gives us a list with 1 card in it. So we want to return the 0th element. This will give us a card rather than a list with a single card. And then we'll do the same thing for def deal hand, but deal hand, aside from self, also takes a number. So we'll just call it num. And it's just going to return self._deal, and then we pass in num. And rather than num, let's go with hand size. I think that's more appropriate for what we're actually dealing with. And we want the list because this is a hand of cards. We want all 5 cards in a list, or 3 cards, or whatever it is. All right, and lastly, we need to deal with shuffle. So shuffle will shuffle a full deck of cards. If there are cards missing, the method should return a value error with the message only full decks can be shuffled. So to actually do the shuffling, I'm going to import random. And actually I'm going to do from random import shuffle. That's the only method I need. So we'll import that shuffle method, and then I'll define my own shuffle down here. Def shuffle self. Okay. And all we want to do is call shuffle, which is not this shuffle. It's this one from random, and pass in self.cards. But remember, we want to add our conditional check to see if self.count is less than 52. So if it's not a full deck, we're going to raise value error, and I think I already copied it. There we go. Only full decks can be shuffled. I didn't specify this, but it is good practice to return self here, even though we don't have to. So I can just prove to you it works. So let's do d equals deck, d.shuffle, and then let's do print d.cards. And if we look, everything is shuffled. Before it was all the hearts up front, all the spades at the end. Now everything is mixed up. We don't have to return self. It won't actually make a difference. But if for some reason we wanted to save it to a variable, we're now capturing self. It's just a conventional thing to do. Okay, so that's a lot of work here, a lot of code. Let's just test things out. So I'm going to make a new deck. I'm going to shuffle it. I'm going to make a hand. I'll call it hand variable, and I'll make it equal to d.deal card. Let's print hand. I'll call that one card. Print card. And then let's do hand equals d.deal hand of 5 cards. And let's print hand. Okay, test it out. And it looks like I didn't execute a method here on deal card. There we go. So it's just telling me, oh yeah, I know that method. Try that again. Okay, so we get a single card, 5 of clubs, and then we get 3 of clubs, 9 of clubs, Jack diamond, 6 of spades, and Ace of diamonds, all in a list when we call deal hand. This time, let's deal a hand of 50. So this should give us we'll take 1 card away, and then we'll deal 50, and then let's do 1 more afterwards, and we'll print that, card 2, and then, well, let's just see what it looks like at the end. So we'll print deck.cards at the very end. I mean d.cards, not deck. And we get first card, second card, and then the 50 that I'm not printing, and then an empty list. And so if we tried to deal 1 more card, we should get an error, because deal card will try and call deal, and deal is going to check if there's 0 cards left, and if that's the case, it should give us an error. And it does. All right. So your implementation might look a bit different, which is totally fine, depending on how you want to structure things. Order of the methods doesn't really matter, other than the fact that I like to put these dunder methods up top, init, repr, all that stuff. And yeah, hopefully you're still alive. It was a long video. By now, hopefully some of this object-oriented stuff makes a bit more sense about how we organize functionality and pieces of information, data, into these classes, and then instantiate objects using those classes. If not, we have plenty more practice. And in the next section, we're going to continue with OOP and talk about some of the trickier parts, some more nuanced things, including inheritance and a fun word called polymorphism, which sounds scarier than it actually is. All right, see you then.